All right, so now to confirm that everything is working as expected, because I did a lot of writing of code, but we didn't actually confirm. But now it's time to confirm. What I'm going to do is I'm going to run this application, and just remember, just based on the nature of the rules that we set in the application.properties, based on the DDL-auto is going to drop the older tables or the tables that are already in the database, and is going to create the new tables based on the entities or based on the entities that we created, such as transaction, account, and user. And I'm going to go into our database and we can confirm it using the terminal. So I'm going to let Kotlin compile, and then I'll go into the terminal and double check if it was created as expected. All right, so it started up as expected and it didn't break, so that's already a good sign. And if you scroll up, and there's usually a lot of configurations, and you can see that it's going to attempt to drop sequences if it was created. Um, it's going to attempt to drop any tables, right, that were created already. And it's going to start the process of creating the table, right? So you can see that it's creating a table for account, transaction, users. It's altering any tables, right, for the specific constraints, right? Because remember, I created a constraint for balance. So you can see that it created that check for it. So you can see that it's being outputted here and it's actually initializing it. But let me go into the terminal so that we can double check that it's there. All right, so here I am in the terminal, and I want to actually go into our running Postgres instance and double check that the tables were created. I saw in Springboot in the output that it was created, and we saw that it created the constraints, but let me go in just to get more confirmation that it was actually created the way that I wanted to. So what I can do here is I can do Docker PS first to see the containers that are running, and I want to get the name of our Postgres instance that is running. So I can see that it's funds app -db. You can also grab the hash if you want, but in this case, I'm just going to grab the name of the container, and I'm going to use that to go inside. So I'm going to do docker exec -it funds app -db, and I'm going to use the bash shell for that. Press enter, and now I'm in. But then I'm going to use psql to interact with our Postgres instance. So I'm going to use psql-h for the host. Local host is going to be the host actually, and -u for the username. And I define the username to be user. And we can press enter from there. And now I'm inside, right? I'm connected as user. And what I can do first, I can list out using \l the different databases inside of this running Postgres instance. So using \l, I can see funds app, which we created initially, and there's Postgres, which is created by default, some other stuff, but I'll use Q to get out of there. And what I'm going to do is use \c to connect to the database that we created, which is funds_app. Then what I'm going to do is I'm going to use \dt to see what tables are here, right? So \dt, and I can see, boom, the three that we created, or the three entities that we created, are now three tables that are in here. So accounts, transactions, users. We provided the name of each one of plural, and it was created by user, which is me, and they're here. Now, if I want to get more details about the table, what I can do is I can do \d plus and provide the name of the table. So accounts will be the name here. Press enter. And as you can see, it provides a lot of information regarding the table, right? We can see the storage type, if it's nullable or not, um, the specific type. So in this case, it's, username is big int. So you can see updated at, which can be a timestamp, the balance, double precision. So it is working as expected. Um, and you can see that there's already some checks there, right? Uh, so yeah, it's working as expected. You can even see that there's a foreign key for the user that's going to be associated to the user ID. So let me quit out of that. So that's going to be for accounts. You can see that it is going to be associating accounts to a user ID, which we defined. And let's do users. And there's a lot here as well. So there's email, first name, last name, password, and they're not null. Go a little bit down. There's the constraint. There's the foreign key. There's the check. It has to be greater than 16 or between the ranges of 16 and 135. So we're seeing what we expect, right? Let me quit out of there. And let me do \d ID plus transactions. And there's to account ID, from account ID. Um, there's amount, transaction type, user ID. Yeah, we're getting exactly what we expect. The primary key is going to be the index. We expected that. So the transaction primary key is going to be the ID. There's a check based on the minimum value. So it has to be greater than 0. And yeah, the transaction type is going to be a text. And you can see that it's going to be the enum value. So you can see the enum values here is transfer, withdraw, deposit. So that is even saying that. So you can see how powerful all this is, right? To be able to define a class and for it to be able to create the checks, provide the enumerated values for us, to create the primary keys, all just by creating a class. That's just the power of Spring JPA. Um, so we'll be utilizing these tables in our application to save transactions, save new users, even confirm that the user exists and to be able to log in, create accounts to associate to a user. So we have the tables now to start that process of getting the ball rolling and getting information into our database, into our tables. So, but at least we're able to confirm that it's structured in the way that we expect and just the sheer power of it all. On to the repositories.